Hi, this is Jim Corkins, and we're going to be doing an introduction to tutorial 5.0. Now, I'm not going to do all of these, but I'm just going to introduce them and kind of help you out with a couple of them, like, for example, this page and the last page. All right? So let's talk about this. So this is about the speed of these ladybugs. You have a ladybug sitting on this this weight A, and it's dropping. You have this wheel that has a radius R, and that's ladybug B is on the edge of that. Then you have ladybug C that is on this rope. This rope, which is attached to this weight, is wrapped around this big wheel, and that big wheel has a radius of 2R, and that big wheel is a radius of 2R, and that is ladybug D, while ladybug E is on a wheel that is radius R, which is basically the same radius as this wheel. Okay, and so the question is about how fast, what are the speeds of all these ladybugs moving, and they're talking about their linear speeds or their tangential speeds, in other words, what your book says. Okay, and then they want to talk about their angular speeds here. Okay, so just quick summary. So the linear velocity of each ladybug is going to be 2 pi r times the omega of that little bug. So this is omega is how fast a wheel is spinning, and so this big wheel spinning is what is determining everything else that is spinning. Again, if this is spinning at the same rate on a record player, all points are spinning at the same rate. So what you would find out is that ladybug E and ladybug D are turning at the same rate. However, their linear velocities are going to be a little bit different. Okay, so their linear velocities are based on their radius. So even though everything has the same omega, their linear velocities of this big wheel determines the linear velocities of C and this guy's linear velocity, as well as A, since they're all connected to this big wheel. So that big wheel has a linear velocity of 2 pi times 2r times that shared omega that everything has. This is spinning at the same rate as all of this other stuff. Okay, so what we're looking for here is that ladybug B, C, actually A, B, C, and D are all dropping at the same velocity as this weight. So if that velocity is the velocity of A, that is got to be equal to the large wheel times its omega of the large wheel, right? And so what you could say is this ladybug here, that omega is equal to this omega, right? Ladybug D and E, while the velocity of everything except for ladybug E is going to be that velocity of that first bug. Now you have to figure out that ladybug E, even though it has omega, it's got a size of just R. So that linear velocity is going to be 2 pi r times omega. While ladybug B, C, and D are equal to this, which is going to be 2 pi times 2r omega. And you know what? I'm just going to copy that. It's that and that. And really, this is the same thing. Okay? So again, since this big wheel is determining all of the velocities here, the velocity of this is spinning at the circumference of the wheel times how fast it's spinning. Well, this little ladybug is moving at that speed. And that speed is also determining this is turning at that speed, and that means this is dropping at this speed. So they're all three of these things, Ladybug D, Ladybug C, Ladybug B, and Ladybug A, they're all dropping at this rate. However, Ladybug E, even though it's right next to it, it's only 2 pi r out from the center. And again, these are all spinning at the same rate, omega. Okay. In page number 2, so there is another part to this page, so you'll have to do this on your own. It's actually easier than what we just did there. But let's do part of the second page. Not the whole thing, just part of it. Okay. So again, you'll have to remember that things that spin clockwise, that's a negative z. And things that spin counterclockwise, that is a positive z. Again, that is in this video of 5.0. Okay, so it's in this video of 5.0 rotational motion. Okay, so please watch that if you get a chance. But continuing on with this, so let's just do the first two right here. So if this ball is rotating, it's going to be turning clockwise. Okay, so it's going to be rotating down this block. So this wheel right here, this ball, when it's going down the first slope, it's going to be rotating, and that's going to be a negative omega or a negative z omega. And it's also going to be speeding up in that direction. So that's also going to be a negative alpha. Okay. But in the x direction, it's going to be moving in the positive x direction. And it's going to be speeding up as it's going down the ramp. So it's also moving in the positive acceleration. So that's both those are the positive x direction. So let me rewrite this. Because you're supposed to put negative z, actually negative omega, and this is negative alpha, and this is going to be positive vx. The velocity in the x direction is moving to the right, and the positive x direction acceleration because it's speeding up. Now, as it's rolling up the next slope, so even though it'll still be turning in the negative omega section, direction, it'll be slowing down. So that's going to be in the positive z direction. So on the second slope, as it's rolling up, it's got a positive, it'll be slowing down as it's rotating clockwise. But it'll still be moving to the right, but it'll be accelerating to the left because it's slowing down as it's moving to the right up the slope. Okay? You could do the rest from here, but this is just a real quick how-to on this tutorial. Thank you.